This lesson will cover your final exam study guide. This will be everything that will be covered on your final exam. Your final exam will consist of, it says 4 parts here, but it's actually 3 parts. There's a typo there. Each part will correspond with that test number. So everything that is on part 1 is going to cover everything you did for test 1. Part 2 will be everything from test 2, and part 3 will be everything from test 3. Each part will consist of between 10 and 30 questions. I will average your grades from parts 1, 2, and 3 if your grade is higher on that part than on the final exam. Like, for example, if let's say you made a 60 on test 1 and you made a 90 on part 1 of the final. So a 60 on test 1 and a 90 on part 1 of the final. Then I'll average those grades together and I'll replace that grade of a 60 with a 75. So there is a lot of room for improvement here. I may have made another deal with you, giving you extra points for parts 1, 2, or 3. If that was the case, then follow what I said in class and not what was said on here, because I may have done something a little bit extra for you in class. So if you do make lower on the final exam than you did on that test, on that corresponding test, then I will not penalize you. So if you made a 90 on part 1 and you made a 60 on that part of the final, then I'm not going to decrease your grade. Your final exam will count as 25% of your final grade in the course. So we're going to look at part 1. This will cover sections 9.1 through 9.4. So this is simplifying rational expressions. Remember, a rational expression is just a fancy name for a fraction. That's all it is. So if I'm going to be simplifying these rational expressions, 8 divided by 4 is 2. And if I have an x to the first divided by an x to the third, when you divide your bases, you subtract your exponents. So 3 minus 1 is 2, so that would be x squared. But since 3 was the bigger number, your x squared goes in the denominator. Okay. Number 2, this rational expression is negative, so that means our answer is going to be negative. So go ahead and put that negative in that answer space. Now, this is understood to be a 1 over 4, so that doesn't change anything. So that 4 is going to stay in the denominator. I've got x to the 6th divided by x to the 3rd. You subtract those exponents, so that leaves you with an x to the 3 up top. And a y to the 3 divided by a y to the 1 would be a y squared, because 3 minus 1 is 2. So my answer here would be negative x to the 3rd y squared over 4. On number 3, 7 goes into 42 6 times. You've got x to the 4th divided by x squared. So 4 minus 2 is 2, and it goes on top because that's where the bigger number was. Y to the 6th divided by y to the 1st is y to the 5th. And then z to the 5th divided by z to the 5th. When you divide something by itself, you have them cancel out and they equal 1. So our final answer is 6x squared y to the 5th. A word of caution: do not leave your answer over 1. If you leave your answer over 1, I would take off half points, because that's not fully simplified. Fully simplified would be 6x squared y to the 5th. Okay? On number 4, you have to look and see, what do I have in the denominator that's common with what I have in the numerator? So I have an x plus 7 in common, so I can cancel those out, and I'm left just with x minus 7. Again, do not leave it as over 1. On number 5, it's not that simple. On number 5, we have to actually we have to actually factor these first before we can divide. So to factor our numerator, we would get x minus 6, x plus 2, And then in the denominator we would get x minus 6, x plus 4. So you look and see, what do our numerator and denominator have in common? They have that x minus 6 in common, so those are going to cancel out, leaving us with x plus 2 over x plus 4. On number 6, we can factor our numerator. That's a difference of squares problem, so it would be x plus 9, x minus 9. And you can't factor x plus 9 down here, so it's just an x plus 9. Now we're going to cancel out what we have in common between the numerator and denominator. So I'm left with just an x minus 9. Page 2 of the study guide. The directions say to multiply or divide as indicated. Express your results in simplest form. So this is section 9.2 on multiplying and dividing these rational expressions. So the first thing you should do is factor. So I would factor this x squared minus 16 to be x plus 4, x minus 4. I would factor my 2x plus 8 to be 2, and then I'm going to pull that out and get x plus 4. That's called taking out the greatest common factor. Then I have my x plus 3 over x minus 4. So we can cancel out cross ways, so diagonally, and we can cancel up and down. What we cannot do is cancel out side by side, so make sure y'all remember that. So my x plus 4 and my x plus 4 will cancel. My x minus 4 and my x minus 4 will cancel. So in my numerator I'm left with an x plus 3, and in my denominator I'm left with a 2. Number 8, again we're going to factor first. So that would leave me with x minus 1 when I factor this out. X squared minus 36 factors to be x plus 6, x minus 6. And then I can't factor these others, so I'm just going to bring them back over. Now this is very critical. I can cancel out these x plus 6's. And I can cancel out this x plus 1 with one of the x plus 1's up here. I cannot say I've got an x plus 1 here and both cancel. That does not work that way. When you have one down here, you can only cancel one with up here. So I'm left with an x minus 1 up top and an x minus 6 in the bottom. Now in number 9, this problem's different. This problem is division. So our rule for division is we have to keep, change, flip. So you keep your x squared minus 49 over x the same, change the division to multiplication, and you flip that second fraction. So x minus 7 moves to the top, and then 7x plus 49 moves down to the bottom. Now I factor, which will give me x plus 7, x minus 7 over x, and then I have my x minus 7 over 7, x plus 7. Now my x plus 7's cancel, and guys, that's it. Nothing else cancels here. These x minus 7's cannot cancel because they are side by side. Remember, you can do diagonally, you can do up and down, you cannot do side by side. So we're left with x minus 7 all over 7x. Okay, so same thing here. You have to keep, change, flip. So I'm going to keep the y squared plus 7y over y squared minus 49. I'm going to leave that. Change the division to multiplication. And then I'm going to flip these two fractions. So that's, or this one fraction. Y squared minus 14y plus 49. And then this goes down here. Y squared minus 6y minus 7. So now I factor. So that gives me y, open parentheses, y plus 7. That's what I get when I factor here. Over y plus 7, y minus 7. That's what I get when I factor that. That's our difference of squares. Up here, when I factor that, I get y minus 7 and y minus 7. And then when I factor down here, I get y minus 7, y plus 1. So my y plus 7 and my y plus 7 here will cancel. My y minus 7 will cancel. Y minus 7 and y minus 7 will cancel. So I'm left with y over y plus 1. So now let's look at number 11. On number 11, it's multiplication, so we can just go ahead and factor. This first one you can factor out of 2, and that leaves you with x plus 3 over x minus 1 times. I can factor a 2 out of there. Remember, your first step is your greatest common factor. So when you pull a 2 out of there, you would be left with x squared minus 2x plus 1. And then you factor what's inside here. So that would be x minus 1 over, and then to factor here it would be x plus 3, x minus 3. So x minus 1 and x minus 1 cancel, x plus 3 and x plus 3 cancel. So I'm left with 2 times 2 is 4, and then we have our x minus 1 over x minus 3. Okay, moving on to number 12. This is division, so we have to do our keep, change, flip first. So I'm going to keep that x squared plus 6x plus 8 over x plus 2. I'm going to change the division to multiplication. And then I'm going to flip this fraction to be 2x minus 8 over x squared minus 16. Now I will factor. This right here will factor to be x plus 2, x plus 4. Bring down your x plus 2. Then I take out this 2 and it leaves me with an x minus 4. This is a difference of squares problem, so that's x plus 4, x minus 4. So my x plus 2's will cancel. X plus 4 and x plus 4 will cancel. X minus 4 and x minus 4 will cancel. So you'll notice you're just left with that 2. You might be tempted to leave it as 2 over 1, but you know that fully simplified it would simply be a 2. Okay. Moving on to the next page. That concludes section 9.2. Now we're going to move to section 9.3. This is over adding and subtracting rational expressions. Rational expressions, remember, just mean fractions. So we're adding and subtracting fractions. We have to have a common denominator when we add or subtract fractions. Well, up here, we already have a common denominator of x plus 8. So when we have that, that means we just combine our numerators. So if I have x plus x, that gives me 2x, and then over x minus 8. On number 14, I have that common denominator, so I combine my numerators. Well, you can't combine 7x and negative 21, so what I'm going to do is just write them side by side like that. Now I need to look and see if they'll simplify. This is what we looked over in section 9.1 on page 1. You need to factor your numerator and denominator and see if anything can cancel. So I can pull out a 7 here, and that leaves me with x minus 3. I can pull out an 8 here, and that leaves me with x minus 3. Your x minus 3's cancel, leaving you with just 7 over 8. Number 15, I have common denominator here, so that means I can go ahead and combine everything from my numerator all on the same line. 20 does not add to either of these terms because they're not like terms, but you can still write them side by side. So that gives me x squared minus 9x plus 20 divided by x minus 4. And then you factor to see if anything cancels. Well, that factors to be x minus 5, x minus 4 over x minus 4. So my x minus 4s are going to cancel, leaving me with just x minus 5. Okay. Looking at number 16, notice now we don't have common denominators. So I need to find that common denominator. Well, they both have an x, but this one has a 6 and this one doesn't. So all I have to do is multiply this denominator and numerator by 6. That gives me 6 times 10 is 60 over 6x plus 7 over 6x. Now we have a common denominator, so I just combine my numerators. 60 plus 7 is 67 divided by 6x. That does not simplify at all, so we're left with 67 over 6x. Okay, on number 17, before we can work this problem, we actually have to factor out this first denominator. So that gives us x plus 5, x minus 5. So I've got x plus 5, x minus 5 here, and I have an x minus 5 here. So all we need to get this to look like this denominator is to multiply by an x plus 5. So I'm left with 10x minus x times x plus 5, and all I did was read from left to right, so 10x minus x times x plus 5, all over that common denominator of x minus 5, x plus 5. Now you guys should not simplify anything, so do not cross anything out until you've combined your entire numerator. That's a big rule. So I distribute this negative x into both terms. So I have 10x, negative x times x is negative x squared, negative x times 5 is negative 5x, over x minus 5, x plus 5. Then I want to write this in descending order and combine my terms. So my negative x squared is written first, and then 10x minus 5x is 5x, and then you have your x minus 5, x plus 5. And I apologize if that just got loud. Apparently we're about to get a thunderstorm, so I apologize if that was loud. So now I'm going to pull out a negative x, because we can't ever have this leading term negative. So when I pull out that negative x, I'm left with x minus 5 over x minus 5, x plus 5. Your x minus 5s will cancel, leaving you with negative x over x plus 5. Now number 18 is more simple. On number 18, we have an x plus 6 over here and an x minus 6 over here. When in doubt, multiply those denominators together. So I can multiply this side by an x minus 6, and I'm going to multiply this side by an x plus 6. So I'm just going to rewrite what I have so far. So that would be 7x times x minus 6 plus, and that's 2 times x plus 6, all over x plus 6, x minus 6. Remember, you cannot simplify anything until you have combined your entire numerator. So I'm going to distribute into these parentheses, which gives me 7x times x is 7x squared. 7x times negative 6 is negative 42x. 2 times x is 2x. 2 times 6 is 12. All over x plus 6, x minus 6. Now I combine my like terms to get 7x squared minus 40x plus 12 over x plus 6, x minus 6. And our next step would be to factor this numerator. So that's our AC method, so let's see if it factors. A is 7, B is negative 40, C is 12. So 7x and 7x on my wings. Up top, we have 84 because that's our A times C, and then our B goes down here. So we want to find out what multiplies to give us 84 and adds to give us a negative 40. All right, so those are all of the factors, that give us 84. So we have to have either a positive times a positive or a negative times a negative. So a lot of y'all might have chosen 2 and 42. But to get a negative 40, we would need them both to be negative. So negative 2 plus negative 42 would give us negative 44, not negative 40. This does not factor. So that means our final answer will be 7x squared minus 40x plus 12 divided by x plus 6, x minus 6. Moving on to 9.4, this is complex fractions, which means a fraction divided by another fraction. I taught you guys to circle your numerator, which is your first fraction, and then circle your second fraction, which would be your denominator, and then write it side by side. So that's x squared over 12 divided by x to the 5th over 18. Then this is division, so you would keep, change, flip. So you keep the x squared over 12, change that division to multiplication, and then you flip that second fraction to be 18 over x to the 5. 12 and 18 will simplify to be 2 and 3. So I have 3x squared over 2x to the 5th. I'm not done, because I have those x's there, I'm dividing my bases so I can subtract those exponents. So that final answer will give me 3 over 2x to the third. 5 minus 2 is 3, and that 3 goes in the denominator because the 5 was bigger than the 2. Number 20. Taught you to circle your top fraction and then your bottom fraction. So I have y plus 1 over y divided by y minus 1 over y. So keep, change, flip. Keep the y plus 1 over y the same. Change that division to multiplication. And then you flip that second fraction to be y over y minus 1. Well, those y's are going to cancel, and I'm just left with y plus 1 over y minus 1. Okay, numbers 21 and 30. All right, these aren't that bad. They're just really long. So you circle the top fraction, and you circle the bottom fraction. So write them out horizontally. So that's x squared minus 1 over x squared plus 8x plus 7 divided by x squared plus 2x minus 35 over x squared plus 5x minus 14. So now I have to do my keep, change, flip. So you keep your x squared minus 1 over x squared plus 8x plus 7. Change that division to multiplication. And then you flip this fraction. So my x squared plus 5x minus 14 goes on top, and then this moves to the bottom, which is x squared plus 2x minus 35. Now I'm going to factor my numerator and denominator of each of these problems. So to factor that x squared minus 1, that's the difference of squares. So that's x plus 1, x minus 1. When I factor this using my AC method, I will get x plus 7, x plus 1. Then when I factor this numerator here, I will get x minus 2, x plus 5. Oops, not 5, 7. Sorry guys. Saw that 5 and I thought 5. So it should be a x minus 2, x plus 7. And then down here, that should be x plus 7, x minus 5. So my x plus 7, my x plus 7 are going to cancel. My x plus 1, my x plus 1 are going to cancel. So nothing else cancels, and that's okay. So I'm left up here with an x minus 1, x minus 2, over x plus 7, x minus 5. On problem number 22, got circle my numerator and then my denominator. So I'm going to write them horizontally first. Then I'm going to do my keep, change, flip. So I'm going to keep this first fraction the same. So that's going to be an x squared minus 3x minus 18 over x squared minus 14x plus 48. Change the division to multiplication. And then I'm going to flip this second fraction. So that's x squared minus 2x minus 8 And then I have x squared plus 4x minus 32. So now I factor. So this would be x minus 6, x plus 3 when I factor this. And then when I factor here, let me see. So x minus 6, x minus 8. Factoring here would give me x minus 4, x plus 2. And then x minus 4, x plus 8. So my x minus 6's are going to cancel. And my x minus 4's are going to cancel. So I'm just left with my x plus 3 and x plus 2. And then at the bottom I'm left with x minus 8, x plus 8. And that's the conclusion of part 1 on the study guide. So for section 2, or part 2 of the study guide, we are going to look at sections 7.1, 7.2, 7.3, 7.5, and 7.6. If you're wondering, 7.4 was part of part 3 of the final exam, so we'll get to that later. So before we can do these first 3 sections, we need to actually know our chart for the perfect squares. I've given this to you before, but I went ahead and put it on the screen just so you could go ahead and take a look at it and rewrite it down if you need to. Just in case you can't read, that should say 8 times 8, 14 times 14, and 15 times 15. So if you need to, pause the video so you can go ahead and get those in there. So they're asking for the opposite on number 23 of the square root of 144. So the square root of 144 is 12. So the opposite of 12 is negative 12. So our answer here would be negative 12. On number 24, the square root of 49 divided by the square root of 25. Well, that can be broken down to be the square root of 49 divided by the square root of 25. Well, the square root of 49 is 7. The square root of 25 is 5. So our answer is 7 over 5. Okay. On number 25, we've got the square root of 9x squared. The square root of 9 is 3, and the square root of x squared is x. Okay. Before we go any further, let me go ahead and give you the perfect cube chart as well. Just so you have it, you will only need to go through 5 on the perfect cube chart. On number 26, that's the 6th root of x to the 6th, y to the 9th, and z to the 13th. Or z to the 3, sorry about that. So I need 6 of a number to release it from the radical. So you can do the long way and write out all of your x's, all your y's, and all of your z's. And you need 6 of a number to pull it out. So I can pull out x's to come out as just one x. You can pull out a pair of 6 y's, come out as one y. And I can't pull out any z's because I need 6 of them to release. So an x and a y come out, and I'm left with the 6th root of y to the 3rd, z to the 3rd. Don't forget that 6 for your index. That will completely change your answer. Or you could have said 6 goes into 6 one time, so an x to the 1st comes out. A 6 goes into 9 one time. That's why a y to the 1st came out, but it had 3 left over, so that's why those 3 stayed in. And then 6 doesn't divide into 3 at all, so the 3 z's have to stay inside. That's an easier way to do these problems. On number 27, I'm going to break 180 down to be 18 times 10, 9 times 2, and 3 and 3. And remember, anytime you get a prime number, you're going to circle it. So a pair of 3's will come out, and a pair of 2's will come out. So that 3 times 2 will give you a 6. And then a 5 stays inside the radical. That's what that is. That's a 5. And then, remember, that's an understood 2. So 2 goes into 7 3 times. So that gives me 3 k's that go out. So then a leftover of 1. So when k to the first stays inside. 2 goes into 8 4 times with none left over. So this is your answer. If you need to actually write out your K's and Q's, that's no problem. I'm just not going to write them all out on this study guide. On number 28, I've got 5 square roots of 3 plus 7 square roots of 3. You have to have the same number under that radical with the same index in order to combine those. Since we do, we just add the coefficients, just like if we had 5x plus 7x. So that will give us 12 square roots of 3. Now on number 29, we have to break down these radicals before we can actually do the problem and do our addition and subtraction. So 72 breaks down to be 8 times 9. 8 is 4 times 2. 4 is 2 times 2. And then 9 is 3 and 3. 32 breaks down to be 8 and 4. 4 and 2. And then 2 and 2. And that 4 is 2 and 2. So this 2 doesn't break down, it's a prime number. So I'm just left with the square root of 2 here minus a pair of 2's comes out and a pair of 3's come out. So 2 times 3 gives you 6, but you have to multiply that 6 by the number in front, which is how you got that negative 30. And then just don't forget you have this 2 here. So square roots of 2. And then a pair of 2's comes out here. And a pair of 2's comes out here. So 2 times 2 is 4. And you have to multiply by the number in front. So you get a negative 12, because 4 times negative 3 is negative 12. And then you have that 2 left under the radical. So I have an understood 1 here. So that's 1 square roots of 2 minus 30 square roots of 2 is negative 29 square roots of 2. We still have this, so we're going to rewrite it. So then we have negative 29 square roots of 2 minus 12 square roots of 2 is negative 41 square roots of 2. And again, we could combine those because we have the same number under the radical on each of them. Then for number 30, we have the same index, which is that little itty bitty 3 up here. You have the same radicand, which is down here under the radical. So you can combine the coefficients. So 3 plus 12 is 15, and that's onto the cubed root of 3. Okay, now moving on to number 31. Got 3 square roots of 5 plus 2 square roots of 45. So that breaks down to be 9 times 5 and then 3 times 3. And that 5 can't break down at all. So I pull out this pair of 3's. So that 3 square roots of 5 doesn't change. This pair of 3's has to multiply by this 2. So 3 times 2 gives us 6. and that 5 stays under the radical. So 3 plus 6 is 9, and then that square root of 5 stays the same. On 32, we have the square root of 2 times the square root of 18, which is the square root of 36, which we know is 6. So when you're multiplying these, I do not recommend breaking anything down until after you have multiplied. It will make your life easier. On 33, 7 times 7 is 49. And then x to the third times x to the fifth is x to the 8, because when you multiply your bases, you add your exponents. And then the square root of 49 is 7. And then that understood index of 2 goes into 8 4 times, so an x to the fourth comes out. Now number 34. 2 times 22 is 44. X to the 4 times x to the 6th is x to the 10, because 4 plus 6 is 10. And that all stays under the radical. So 44 breaks down to be 2 and 22. 22 breaks down to be 2 and 11. So these 2's are going to come out of the radical, and 5 10's will come out, or I'm sorry, 5 x's will come out. So an x to the fifth comes out, and you're still left with this 11 under the radical. Now on 35, this can get a little bit tricky, so you've got to take it slow. You've got to imagine that you've got ones in front of both of those terms. So your 2 is going to multiply by those ones in front, and the square root of 5 will multiply by what's under those radicals. So 2 times 1 is 2. 5 times 11 is 55, and that's still under the radical. 2 times 1 is 2. And then 5 times 5 is 25. Now I can't add these together because they don't have the same number under the radical, but I can break down that square root of 25. So that gives me 2 square root of 55 plus 2 times 5, because the square root of 25 is 5. And we can finish that up by doing 2 onto the square root of 55 plus 2 times 5 is 10. Okay. So now on number 36, we're going to distribute. So I can't multiply the square root of 7 times the 5 because the 7 is under the radical and the 5 is not. So you would just write it as 5 onto the square root of 7, the 5 just goes in front, plus square root of 7 times the square root of 7 is the square root of 49. And then I can break 49 down to be 7. You cannot combine these together because they don't have the same radicand, so we are finished. On number 37, we are going to distribute the square root of x times everything in that second set of parentheses, and that 9 times everything in that second set of parentheses. So the square root of x times the square root of x is the square root of x squared. The square root of x times negative 9 is negative 9 square roots of x. 9 times the square root of x is 9 square roots of x. 9 times negative 9 is negative 81. So this right here is going to cancel. So you're left with, well, the square root of x squared is just x, and then you bring down your minus 81. And you're finished. On 38, you have to actually break this up to be a 5 plus the square root of 7 times a 5 plus the square root of 7. If you ever had, like, let's say 5 squared, then you would write it out as 5 times 5. Same concept. We're writing this out times itself this many times. Okay? So the 5 multiplies by each of these terms, and the square root of 7 multiplies by each of these terms. So 5 times 5 is 25. 5 times the square root of 7 is 5 square roots of 7. Then the square root of 7 times 5 is 5 square roots of 7. The square root of 7 times the square root of 7 is the square root of 49. Now I can combine these two terms to get 25, and then 5 plus 5 is 10 square roots of 7, plus the square root of 49 is 7. And then you can combine your like terms here. 25 plus 7 is 32 plus 10 square roots of 7. Okay, now looking at number 39, we are going to distribute that square root of 6 into each of those terms and our 7 into each of these terms. The square root of 6 times the square root of 2 is the square root of 12. Square root of 6 times 3 is 3 square roots of 6. 7 times the square root of 2 is 7 square roots of 2. 7 times 3 is 21. Now that 12, I'm going to do it up in this corner here so I have room. That's 4 times 3 and 2 times 2. So a pair of 2's will come out, and that 3 stays under the radical. You can't combine these two terms because they don't have the same number under the radical, and the 6 and the 2 don't break down, so you just bring them down. And then 21 doesn't have any like terms to combine, so it's just 21. I know that doesn't feel right, but I promise that is the answer. That's your full answer. Okay, so the square root of 2 times everything in this set of parentheses, and then 4 times everything in this set of parentheses. So the square root of 2 times the square root of 7 is the square root of 14. Square root of 2 times negative 3 is negative 3 square roots of 2. Then 4 times the square root of 7 is 4 square roots of 7. 4 times negative 3 is negative 12. None of these radicals will break down, or these radicands, they won't break down. Nothing has a like term, so that is our answer. Now in 41 through 43, this is over rationalizing the denominator. There is a full video dedicated on how to rationalize the denominator. So feel free to check that out if this review is not enough of a review for you. So I need to get that radical out of the denominator. So I'm going to do that by multiplying by the square root of 2. Because when I do that, that'll give me 9 square roots of 2 in the numerator, but I'll end up with the square root of 4 in the denominator. Square root of 4 breaks down just to be 2. So again, the reason we did that is so we have 1 2, we need one more 2 to release it from the radical. Once we multiplied by that 2, it came out of the radical. These 2's cannot simplify because this one is under the radical, this is not. They both have to be outside of the radical in order to simplify. Number 42, same type of problem. You are going to multiply by the square root of 21. So I'm left with 8 onto the square root of 21 over 21. You could go through all the hot mess of multiplying 21 times 21 and then finding the square root of that, or you just know that when you have two 21s under the radical, they come out as just that 121. These do not simplify because these don't have anything in common, and this is under the radical, this is not. Number 43, this one's different. I have to multiply by what's called the conjugate. So the conjugate of 9 minus the square root of 3 is 9 plus the square root of 3. And when I do that, I distribute this 7 into each of those terms. So 7 times 9 is 63. 7 times the square root of 3 is 7 square roots of 3. And then 9 times everything in here, negative square root of 3 times everything in here. So 9 times 9 is 81. 9 times the square root of 3 is 9 square roots of 3. Negative square root of 3 times 9 is negative 9 square roots of 3. Negative square root of 3 times the square root of 3 is negative square roots of 9. These are going to cancel. So I'm left with 63 plus 7 square roots of 3 over, I've got my 81, and the square root of 9 is 3. So I have 63 plus 7 square roots of 3 over 78. Okay. Now moving on to section 7.5 of rational exponents. All right, so this is when you have the base and to the power over root. And you have to translate it to where your base is here, your power is here, and your root is there. The way I remember which is which in this fraction, you have your own beliefs. That is perfectly fine. This is just how I remember it. I think of God being the almighty power is up top, and then roots grow in the ground, so they're on bottom. So that's how I remember power is up top and root is on bottom. So now I've got 49 to the 1/2 power. So translate that and you get 49 to the first power on taking the square root of it. So the square root of 49 is just 7. So now I've got 27 over 8 all to the 1/3 power. So the power is the root is 3. And that's 27 over 8, all to the first power. So I can rewrite that to be the cubed root of 27 over the cubed root of 8. Cubed root of 27 is 3. Cubed root of 8 is 2. On number 46. I'm not sure if you can see it very well with the camera because it seems like it's blending in, but this is a 27 to a negative 1/3. So whenever you have a negative exponent, you take that and the base it's attached to and move it to the other side of the fraction. So your 27 to the 1/3 is now positive 1/3. You have to have a placeholder in the numerator, so you're just going to write a 1. Now, 27 to the 1/3 translates to be the cubed root of 27 to the first, and the cubed root of 27 is 3. So that would be 1/3. Simplify each expression and assume that all variables represent positive real numbers. Number 47 is always the most commonly missed problem in this unit, so please make sure you pay attention. So on these, you are going to need to get a common denominator. The reason is because when you multiply your bases, you are going to add those exponents. So we're adding 5 over 6 and 2 over 3. But to add these, you have to have a common denominator. And in this case, your common denominator is 6. So that gives us p to the 5 over 6 times p to the 4 over 6. And then when you combine those together, you've got 5 over 6 plus 4 over 6 is p to the 9 over 6, which simplifies to be 3 over 2. All right, so now on number 48, same thing, it's just dividing. So when you divide your bases, you subtract your exponents. Still have to have a common denominator when you are subtracting fractions. So that gives me w to the 7 over 6 over w to the 3 over 6. So 7 minus 3 is 4, so that's w to the 4 over 6. And then to simplify that, you would get w to the 2 over 3. On 49, that is called raising a power to another power, which means you are going to be multiplying these exponents. So that would give us p, 3 times 2 is 6, 4 times 3 is 12, and then you would simplify 6 over 12 to be p to the 1/2. So it looks like my camera decided to freeze on me. So if you did end up missing that view of number 49, I'll talk you through it again. We are raising a power to a power, so that means we're going to multiply these two fractions. So 3 times 2 gave us 6, 4 times 3 gave us 12, and 6 over 12 simplifies to be 1 over 2. So your final answer is p to the 1/2. Sorry about that, guys. So on number 50, we are still raising a power to a power. So you're going to distribute this 4 into each exponent inside of that set of parentheses. But the thing you need to make sure you understand is that that 3 also has its own exponent of 1. So you actually have to multiply that 4 times that 1 as well. So that gives you 3 to the 4th power, and m, that's 3 over 4 times 4 over 1. Because if we wanted to make that 4 a fraction, we would write it as 4 over 1. And then n to the 5 over 4 times 4 over 1. So 3 to the 4th power is 81. Just think about it. So you multiply 3 times itself 4 times. 3 times 3 will give you 9. 3 times 3 gives you 9. And then 9 times 9 is 81. So that's how I got the 81. Okay, that gives you m. 3 times 4 is 12. 4 times 1 is 4. And then n, 5 times 4 is 20. 4 times 1 is 4. So now I have 81 m. 12 divided by 4 is 3. 20 divided by 4 is 5. So that's 81 m to the 3 n to the 5. Now number 51, we can do a couple of different things first. You can either move these negative exponents first and then distribute, or you can distribute first and then move your negative exponents. I always say don't move the negative exponents until after you have distributed, just because if that was a -2, you would end up having to redo all that work you just did. So we're going to distribute first. Multiply 2, sorry for the cat meow, 2 times every exponent inside of that set of parentheses. So that is a to the 1/3 times 2/1, b to the -1/6 times 2/1, over c to the -1/6 times 2/1. So you'll end up with a to the 2/3, b to the -1/3. And the way I got that was because 2 goes into 2 once, 2 goes into 6 3 times, over c to the -1/3. Same reasoning. 2 goes into 2 once, 2 goes into 6 3 times. Then we are going to move these. The a to the 2/3 does not move because it is already positive in the exponent. So your c to the 1/3 moves up top. Your b to the 1/3 moves down to the bottom. Just for a little bit of information, your c should go at the end because a comes before c in the alphabet. So your answer will be a to the 2/3, c to the 1/3, over b to the 1/3. Now for section 7.6, this is the last section of this part of the final exam. You draw your eye chart. So that's I to the first, I to the second, I to the third, and I to the fourth. And what do you say when you win a baseball game? I won, I won. And then we always want to keep those negative people on the inside. We don't want them to go out and spread their negativity. So those would go on the 2 inside numbers. That is your eye chart. So write the answer in terms of I. The definition of an imaginary number is the square root of a -1. So anytime you have a negative that is under a radical, then it will come out as an I. So the square root of 16 is 4. The square root of a negative is I. Pretty sure your study guide answer key shows something other than this number. I apologize for that mistake, but it should be 4i. Number 53. Okay, so they're asking for the opposite of the square root of -121. Well, the square root of 121 is 11, and the square root of a negative is going to be I. So the opposite of that would be -11i. Number 54, the opposite of the square root of -23. Well, 23 can't be broken down. It's a prime number, but we can pull out this negative as an I. So you write your 23 under the radical. The I goes in front. So the opposite of I square roots of 23 is -I square roots of 23. And then on number 55, 24 breaks down to be 6 times 4. 6 breaks down to be 2 times 3. 4 breaks down to be 2 times 2. So these 2's break down and they come out as 1, 2. And 2 times 3 stays in the radical as 6. But we can still take out this negative as an I. It goes right here. So now 56 through 60, we are adding and subtracting complex numbers. You have to have common terms in order to combine these terms, okay? And remember, standard form is A plus BI. So your 2 questions you ask, can you combine these 2 terms? No. Is there anything multiplying out in front other than that 1? No, so it can be released. Same thing here. Can't combine these two terms. There's nothing but a 1 multiplying out in front, so it can be released from that parentheses. And now you combine your like terms. 8 plus 7 is 15. Negative 9i plus 2i is negative 7i. Just make sure it's in that a plus bi form. A being the constant, the number by itself, and the I being the imaginary number. Can't combine these two terms. Nothing multiplies out in front, so you're left with 4 plus 2i. Can't combine these two terms. Nothing multiplying out in front, so you bring down that 3 minus 5i. Now you combine your like terms. 4 plus 3 is 7. 2i minus 5i is negative 3i. Now number 58. You can't combine these two terms, and there's nothing multiplying out in front, so 5 plus 6i releases from the radical, or from the parentheses. Sorry about that. You can't combine these two terms. However, there is a negative 1 multiplying out in front. So in subtraction, you've got to be careful of that. So this negative 1 is going to multiply by each of those terms inside of that set of parentheses. So negative 1 times negative 4 is a positive 4. Negative 1 times I is negative I. Now you combine your like terms. 5 plus 4 is 9. This has an understood 1 in front. So 6i minus 1i is 5i. Can't combine these two terms. There's nothing multiplying out in front, so you can release this from that parentheses. Can't combine these two terms, but there is that negative 1 multiplying out in front, so that means that you need to distribute that negative 1. Negative 1 times negative 6 is positive 6. Negative 1 times I is negative I. So I'm going to combine my like terms. 4 plus 6 is 10. This is understood to be a 1 in front of that I. So 3i minus 1i is 2i. And then finally on number 60, can't combine these two terms. There's nothing multiplying out in front. So that's 8 minus 2i. Can't combine these two terms. And this is addition. So there's nothing multiplying out in front other than that 1. So that 9 plus 6i is released. So you combine your like terms. 8 plus 9 is 17. Negative 2i plus 6i is 4i. Now in 61, you multiply them together. So 3 times 2 is 6. I times I is I squared. Now if you look back at that I chart that we did on page 8, so we have 6i squared. So I squared translated on that chart is negative 1. So we're going to replace that I squared with negative 1, which 6 times negative 1 gives you negative 6. Okay, now for the last page of the Unit 2, or Part 2 of the study guide, we are going to distribute this 5i into each term in that set of parentheses. So 5i times 2 is 10i. 5i times negative 4i is negative 20i squared. We know I squared translates to be negative 1. Negative 20 minus 1, or times negative 1 is positive 20. And you have to put it in that standard form, which is a plus bi. So your 20 should come first, then your 10i. Number 63, you multiply the 2 times everything in this side of the parentheses, and then your 3i times everything in this set of parentheses. So 2 times 5 is 10. 2 times negative I is negative 2i. 3i times 5 is negative 15i. 3i times negative I is negative 3i squared. Now we can combine our like terms. So that's 10, negative 2i minus 15i is negative 17i. And then this I squared is a negative 1. So I'm going to replace a negative 1 with that I squared. Then negative 3 times negative 1 is a positive 3. And now I have like terms I can combine, which would be 13 minus 17i. On number 64, that would be 3 minus 4i times 3 minus 4i. So 3 times everything in this set of parentheses, negative 4i times everything in this set of parentheses. So 3 times 3 is 9. 3 times negative 4i is negative 12i. Negative 4i times 3 is negative 12i. Negative 4i times negative 4i is positive 16i squared. So now I can combine these two terms, which gives me 9 minus 24i plus 16, and I squared is negative 1. So that's 9 minus 24i. 16 times negative 1 is negative 16. And then you combine your like terms. 9 minus 16 is negative 7. And then bring negative 24i over. Just make sure it's in that a plus bi form. Now on number 65, we have to get that I out of the denominator, because remember the I is considered a square root of negative 1. You can't ever have a square root in the radical, or at least in the denominator of the fraction. So I'm going to multiply by the conjugate. Remember, the conjugate is always the same binomial, except you change the sign that connects your two terms. So 6i times 2 is 12i. 6i times negative 5i is negative 30i squared. Then I have 2 times everything in the set of parentheses, and 5i times everything in the set of parentheses. So 2 times 2 is 4. 2 times negative 5i is negative 10i. 5i times 2 is 10i. 5i times negative 5i is negative 25i squared. So we'll notice that these will cancel. So we have 12i minus 30 times negative 1. I get up from here, over 4, those cancel, minus 25, and I squared is negative 1. So now I have 12i, negative 30 times negative 1 is positive 30, over negative 25 times negative 1 is a positive 25. So we want this to be an a plus bi form. So I want that 30 to come first and then the 12i. 4 plus 25 is 29. Can't simplify any of this, so we are finished. Simplifying each power of I. On test 2, I told you that this was just going to be bonus material, but on the final exam it would actually count as real points. So understand that these are counting as real points on this final exam. So we will divide this exponent by the number 4. So 4 goes into 10 2 times. 4 times 2 is 8. 10 minus 8 is 2. So the remainder you get, you plug it into your I chart, which I squared we know is -1. So our answer is -1. If you are looking for the why, as in why this works, please visit the section 7.6 video. So on number 67, you divide your exponent of 61 by 4. 4 goes into 21 5 times. So our I to the first translates just into I. 100 divided by 4. Anytime you have a 0 for your remainder, your answer will always be 1, because anything to the 0 power is 1. And then I would divide my 203 by 4 for number 69. So 4 does not divide into 3, so I to the third is -I. Okay, all right, so that concludes part 2 of the study guide. Okay, so on part 3, we will start off by solving by factoring. We will factor these binomials. Remember, you have to make sure it's set equal to 0 first. So to factor, I would get x minus 7, x plus 2. And the only way we can make this true, to where this equals 0, is if either this x minus 7 turns out to be 0, or the x plus 2 turns out to be 0. So we set each of these binomials to 0. So you add 7 to each side, subtract 2 from each side, which gives you x equals +7 and x equals -2. For 71, you have to set this equal to 0 first. So you have to subtract 10 from both sides. So I get 3x squared plus x minus 10 equals 0. So you have to factor that. So we're going to use the AC method and find out what multiplies to give us -30 and adds to give us a +1. So 6 and -5 will work. And then you simplify here. If you are looking for more in-depth on how I factored this, you can look at my factoring the AC method video. You can also look at the section 8.1 notes. So that's 3x minus 5 and then x plus 2. You set them equal to 0. So you set each of these equal to 0. So that's 3x minus 5 equals 0. X plus 2 equals 0. So you're going to add 5 to each side to get 3x equals 5. And then you divide both of these by 3 to get 5 over 3 for my first answer. Subtract 2 from both sides here to get x equals -2 for this answer. My quadratic formula, remember you have your two songs. First song is like the row, row, row your boat theme song. So negative b, plus or minus square root, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. You can also use the Pop Goes the Weasel theme song. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. I hope those songs are helpful to you. So that's negative b plus or minus the square root of b squared minus 4ac all over 2a. So on number 72, we are going to solve this problem by using the quadratic equation, which we just wrote up here. So your first thing you should do is identify your A, B, and C. Your A is 1, your B is 3, and your C is going to be a negative 27. Remember, we cannot solve this by any method until we get this equal to 0. So that would have given our new equation x squared plus 3x minus 27 equals 0. That's why C is 27. So quadratic formula, right up here. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So that would give us a negative 3 here plus or minus the square root. 3 squared is 9. Negative 4 times negative 27 will give us a positive 108 all over 2, which is negative 3 plus or minus the square root of 117 all over 2. Do not see this 117 and think that we are done. 117 can be broken down. 3 goes into 117 39 times, and then 3 goes into 39 13 times. So a pair of 3's will come out. So they come out here, and you're left with that 13 under the radical, all over 2. So this would be your final answer here. Nothing will simplify. So we're done there. Now for 73, identify your A, B, and C first. A is 2, B is negative 2, and then C is negative 1. So that's negative B plus or minus the square root of b squared minus 4ac, and that's all over 2a. So that's saying the opposite of negative 2, so that's a positive 2, plus or minus the square root. Negative 2 squared means negative 2 times negative 2, which is a positive 4. Negative 4 times 2 is negative 8. Negative 8 times negative 1 is a positive 8. And then 2 times 2 gives us a 4 here. So now I'm going to combine my terms under the radical to get 2 plus or minus the square root of 12 all over 4. And the square root of 12 breaks down to be 4 times 3 and then 2 times 2. So a pair of 2's comes out. You have the 3 that stays in all over 4. And then finally you can separate these terms to both be over that 4. So that would give us that 2 over 4 plus or minus the 2 square root of 3 over 4. Each of those simplifies to be 1/2. So you're left with 1 plus or minus the square root of 3 over 2. If you wanted to, you could also see this as the triangle we've talked about. 2 goes into each of these 3 numbers. So 2 goes into 2 once, 2 goes into 2 once, and 2 goes into 4 twice. You would get the same thing. Number 74, solve each equation. Be sure to check your solutions. So we need to get rid of that radical sign. So to do that, we will square both sides. When you square this left side, that gets rid of the radical, leaving you with just 8x minus 7. And when you square that 7, that gives you 49. Then you solve for x. Add 7 to each side. 8x equals 56. Divide both sides by 8. X equals 7. So now I'm going to check x equals 7. I'm going to plug 7 in place of my original equation. So that's 8 times 7 minus 7 equals 7. So 8 times 7 equals 56. Bring down your minus 7 and bring down your other 7. 56 minus 7 is 49. Square root of 49 is 7. Since 7 equals 7, our answer of 7 is correct. Make sure you check each of these problems on numbers 74 through 79. Okay, so on number 75, the first thing we're going to need to do is to get this radical by itself. So I'm going to add 2 to each side, which gives me the square root of 4x minus 2 equals 2. And I'm going to square both sides to get 4x minus 2 equals 4. So now I need to solve for x. And I'm going to add 2 to each side, which gives me 4x equals 6. And then I'm going to divide both sides by 4 to get x equals 3/2. So now I'm going to check x equals 3/2. So I plug that 3 over 2 in place of that x. Okay, so 4 times 3 is 12, 1 times 2 is 2. So that gives me 12 over 2 minus 2, and then bring down this minus 2 equals 0. All right, 12 divided by 2 is 6. Bring everything else down. 6 minus 2 is 4. Square root of 4 is 2. 2 minus 2 is 0. So since 0 equals 0, we know that our answer of 3 over 2 is correct. 76, get that radical by itself first to get the square root of 4x equals 4. Square both sides to get 4x equals 16, and then divide both sides by 4 to get x equals 4. So now we will check x equals 4 by plugging 4 into this x. So 4 times 4 is 16. Excuse me. Square root of 16 is 4. 4 plus 5 equals 9. So since 9 equals 9, that's a true statement. So that means that our answer of 4 is correct. Now number 77, subtract 2 from each side to get the square root of 3x equals 9. Then you square both sides to get 3x equals 81 because 9 squared is 81. And then you divide both sides by 3 to get x equals, 3 goes into 81 27 times. So now I'm going to check that x equals 27. So I'm going to do that by plugging in 27 in place of my x. 3 times 27 is 81. Square root of 81 is 9. 9 plus 2 is 11. Since 11 equals 11, we know our answer of 27 was correct. 78. This one's a little different, a little bit harder, just like 79 is. So we square both sides. That gives me 15 minus 2x equals x squared. So now I need to move everything on the same side as the x squared. So I'm going to add 2x to both sides to get 15 equals x squared plus 2x. And then I'm going to subtract 15 from both sides to get 0 equals x squared plus 2x minus 15. Now I factor that trinomial to get x, let's see, plus 5x minus 3. And then you set each of those equal to 0. And solve, just like we did on section 8.1 on numbers 70 and 71. So now since we got two answers, we have to check both answers. So I'm going to check x equals -5. So I'm going to plug it into all of my x's. So -2 times -5 is positive 10. 15 plus 10 is 25. Square root of 25 is 5. 5 does not equal -5. So I know my answer of -5 does not work. So let's try our answer of 3. So we plug in 3 in for all of our x's. So that gives me -2 times 3 is -6. 15 minus 6 is 9. The square root of 9 is 3. So since 3 did work, that means that 3 is my only answer. Remember, if both answers worked, they both would be my answer. If neither of those answers work, then that means that I would have written no solution. Now let's look at the next problem, which is number 79. So I'm going to square both sides to get x plus 5 times, oops, sorry y'all, to get x plus 5, because it just comes straight out of the radical as 1. And then I have x minus 1 times x minus 1. If you were to distribute this out, distributing this, you would get x squared, because x times x is x squared. Then x times negative 1 is negative x. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. Now I'm going to combine all of those like terms. So bring that x plus 5 down. Negative x minus x, you would get negative 2x. And then I would subtract 5 from each side. And then I would subtract x from each side. Remember, you've got to get everything on the same side as that x squared. So I would factor that out to be x minus 4, x plus 1. And then I would set both of those equal to 0. So you would add 4 to both of these to get x equals 4. Subtract 1 from both of these to get x equals negative 1. So now I have to check both of these. So check x equals 4. So I plug that into all of my x's in my original equation. So 4 plus 5 is 9. 4 minus 1 is 3. Square root of 9 is 3. 3 equals 3, so 4 is definitely a solution. So now I'm going to check x equals negative 1. So I'm going to plug negative 1 in place of my equation. So negative 1 plus 5 is 4. Negative 1 minus 1 is negative 2. The square root of 4 is 2. 2 does not equal negative 2. So our answer of negative 1 is not a solution. So the only answer we have here is 4. Now let's look at number 80. Number 80, we need to find out what we're going to multiply by to get rid of our denominators, because nobody likes fractions, so let's get rid of them. So I'm going to multiply by 4x. So when I do that, my x here and my x here cancel. My x here and my x here cancel. And my 4 here and my 4 here cancel. So I'm just left with 4 times 5 minus x minus 7 times 4 is 28. Equals, notice how this is negative, so that's negative 3 times x, so that's negative 3x. Very easy mistake to make. So you distribute this 4 to get 4 times 5 is 20. 4 times negative x is negative 4x. Bring down your negative 28 and your negative 3x. Now you're just solving. So combine that 20 and negative 28. Bring your negative 4x down. So 20 minus 28 is negative 8. Now I'm going to move this 4x over to get negative 8 equals x. Now before we move on, you have to consider excluded values. Your excluded values are what you get when you would get a 0 for your denominator, okay? These are solutions you cannot ever get. So here, my x's were in the denominator. The only number I could plug into those x's to get a 0 down here would be 0. So our excluded value would be 0. So looking at number 81, I'm going to put that 1 over 1 so I can see what all of my denominators are. So I'm going to multiply everything here by a 5x. And while I still have my x there, my excluded value here is 0. Because if I plug 0 in place of here, that would give me a 0 for the denominator, which we can never have. So as long as we don't get 0 for an answer, we'll be good. So these x's here are going to cancel. These 5's here are going to cancel. So you should have 5 times 3 is 15. X times 4 is 4x. 5x times 1 is 5x. So now you solve by subtracting 4x from each side to get 15 equals x. It's not our excluded value, so we're good to go. Now before we can work this down here, we have to factor all of our denominators. So this just needs to be factored to be x plus 2 and then x minus 2. It's a car problem. Okay, so now our common denominator we're going to multiply by is x plus 2, x minus 2. And I just write them up and down just because it saves space. So my x plus 2 is going to cancel. X minus 2 is going to cancel. And then my x plus 2 here cancels. And my x minus 2 here cancels. So to ensure you're not going to make a mistake, go ahead and write out what you have first. So I'm going to multiply a 5 times x minus 2 first. Then it's negative 7 times x plus 2 equals 4. You're not multiplying that 4 times anything because everything canceled out. So you distribute this 5, and that gives you 5 times x is 5x. 5 times negative 2 is negative 10. Negative 7 times x is negative 7x. Negative 7 times 2 is a negative 14. So now you combine your like terms. 5x minus 7x is negative 2x. Negative 10 minus 14 is negative 24 equals 4. Then you add 24 to both sides to get, and I'm going to bring it up here, negative 2x equals 28, because that negative 2x just carries over, those cancel, and then 4 plus 24 is 28. Then you divide each of these by negative 2, so you're left with x equals negative 14. Your excluded values here were positive 2 and negative 2. If you had set both of your denominators equal to 0, you would have seen that 2 and negative 2 would have been your excluded values. So your answer is negative 14. On number 83, your excluded values are 3 and negative 3. Again, you get that by setting each of these equal to 0 and then solving. So I'm going to first factor this x squared minus 9 to be x plus 3, x minus 3. And then I find my common denominator, which would be x plus 3, x minus 3. So my x plus 3's are going to cancel. My x minus 3's are going to cancel. And then up here my x plus 3's cancel. And then my x minus 3's cancel. So I'm left with 6 times x minus 3 minus 9 times x plus 3 equals 3. And then you distribute. So 6 times x is 6x. 6 times negative 3 is negative 18. Negative 9 times x is negative 9x. Negative 9 times 3 is negative 27. 6x minus 9x is negative 3x. Negative 18 minus 27 is 45, negative 45. So now we add 45 to each side. Then you divide both sides by negative 3 to get x equals negative 16. None of those were excluded values, so we are good to go. Negative 16 would be a good answer. I know it says at the bottom of your test that you are going to have a part 4 to your final exam. I lied. I'm so sorry. But you actually are not going to have part 4 anywhere on your final exam. So please disregard this one little section. I've been meaning to take it out and just haven't done so. So I wish you the best of luck on your final exam. Remember, there are only going to be 3 sections to your final, and I wish you the absolute best of luck.